Well, hello guys, here Mr. G. Take paper, take a ruler. We're going to answer the final question of this test that we done on electric circuit. And the final question is going to be question 1. I like to leave question 1 always for last because question 1 multiple choice could be tricky. Not necessarily this is the case. Now question 1 in this one said which one of the first question 1.1 said which one of the following is the unit measure for the rate of flow of charge. Now, rate of flow of charge. In other words, rate of flow of charge is when you divide it by time, so will be charge divided by time. And that one, according to this formula, is going to be current. This is rate of flow of charge. Okay, guys, that is current, and therefore the answer is going to be A, ampere. Quite simple, the first one. Second one, in the circuit represented below, the internal resistance of the battery is negligible. So the internal resistance is not going to be playing a part in this circuit. And the switch S is open. Okay? Which one of the following combinations correctly represent the changes in the reading of the ammeter and the voltmeter when the switch is closed? Now, if you let's look at something here. The current is going to flow in this direction there. So it's going to flow all the way there. Now, when you go to this point here, it goes straight, right? But if the switch is closed, close it here, what is going to happen? Because the conducting wire in the switch, there is not resistance. All the current will flow through this way instead. So no current will flow through the resistor. So as you take in one resistor in series, that means that the total external resistance is going to decrease, going to be less. Alright, if we go to Ohm's law, in which resistance is equal to potential difference divided by current, and then what is going to happen? So let's speak first about the current. What is going to happen to the current? Well, because the total resistance is less, then the current, as you can see there, is going to be more. More current is going to increase. So if we come here, then the options are either A or D. Those here are the two options we have. Either one, okay? The current is going to increase. But now, what is going to happen to the potential difference, to the voltmeter? Now, this one is just for this resistor. Note, in this case, resistance is constant because we're working with just that little part there, okay? But the current that is flowing through that resistor is going to be more because it's the one that is going there. So current is more. Therefore, what happened to the potential difference, remember, is the product of current multiplied by resistance. If resistance is constant and the current is more, so thus the potential difference is also going to be more. And then let's look, the potential difference here is going to be also more. So which one is the correct answer? The correct answer must be then D, in which the current is more but the potential difference is also more. Okay, so let's go to the next question. That one was quite simple. Which one of the following graph best represents the relationship between the electrical power and the current in a given ohmic conductor? Now, if we go to the formulas here, in a given ohmic conductor, we means that the resistance is going to be constant because we're working with one specific conductor, which is ohmic, and then they want to know the relationship between power and current. So this one will be the one that is going to help us to answer that specific question. So what formula is going to help us? Power is equal to a current to the power 2 multiplied by resistance. Now, if you come here, you can see that the power is directly proportional to the square of the current. All right, so it is not going to be straight line. They are directly proportional, but not in a straight line because the current is in is a square. So the correct answer here is also going to be D. Is also going to be D. So let's go to question 1.4. And but for this question, I think there is a very important note we must take. We must know that the equivalent resistance of the parallel connection, and this one is a general note I want you to write, will always be smaller than the smaller resistor. And I think this is a quite important note to take and write down in your book immediately. The equivalent resistance of the parallel combination will always be smaller than the smaller resistance, obviously, of the parallel. We're talking about the parallel combination. I think it's an important note because this note, guys, can help you to identify if your calculation is right or wrong. So let's please write it down in a piece of paper, in your book, wherever you have a space there. So saying that, if we go back to the question, two resistors X and Y are connected in parallel, resistance of Y is greater than resistor of X. So the correct answer will be C. The correct answer is C. The equivalent resistance of the parallel connection will be smaller than resistance X because X is smaller. Guys, quite simple. And 1.5 is the last question. I don't know what happened there. I'm sorry, I touched the wrong place in the screen. So here we go. The three resistors in the circuit diagram shown below are identical. If the reading of ammeter A is I, what will the reading of ammeter 2 be? And this one I'm going to leave it open for you. So write in the comments the correct answer if you will, and then we'll mark it there. But guys, this is the end of the video. Thank you for watching. I hope it helped. If it helped, thumb up, subscribe for the channel. I'll see you next time with more questions and more videos. Mr. G here.